Good day, everyone. I am Rika Gula.
And I am Ethel Grace Kalinawan. And we are going to share what we understand towards simultaneity and the relativities of time, length, and velocities through this podcast.
First, we will talk about what is simultaneity. For you, Ethel, what is simultaneity?
Well, I learned that relativity of simultaneity is a concept in a special relativity. Simultaneity is the relation between two events assumed to be happening at the same time in a frame of reference.
Yes, as far as I understand, in physics, the relativity of simultaneity is the concept that distance simultaneity, whether two spatially separated events occur at the same time, is not absolute but depends on the observer's reference frame.
According to Einstein's special theory of relativity, it is possible to say in an absolute sense that two distinct events occur at the same time if those events are separated in space.
And that if one reference frame assigns precisely the same time to two events that are different points in space, a reference frame that is moving relative to the first will generally assign different times to the two events.
Now, we are going to proceed to the relativity of time. So, it is the phenomenon that says time in two inertial reference frames moving with respect to each other will appear to be different. And the time intervals on a speeding rocket will appear to be longer to you than to the people on the ship.
Insights, Ethel. Now I'm gonna talk about the relativity of length. According to special theory of relativity, length contraction is the phenomenon that a moving object's length is measured to be shorter than its proper length, which is the length as measured in the object's own rest frame. This contraction is usually only noticeable at substantial fraction of the speed of light. The length of an object measured in the rest frame of the object is its proper length or rest length. Measurements of the length from any reference frame that is in relative motion parallel to that length are always less than the proper length.
That's a great explanation, Rika. And now we're gonna talk about our last topic, which is the relativity of velocities. So, the relativity of velocities is when a particle is moving with a speed in the positive direction in an inertial reference frame that itself is moving with speed parallel to the direction of a second inertial frame. The speed u of the particle as measured in s is in this formula, which you can see on this side of the screen.
Thank you for that, Ethel. That's all for today's podcast. We hope that you learned a lot from our discussions.
Thank you for watching, and let's meet again next time. Bye!